Welcome to Neon Math. Our objective today, solve two-step algebraic equations using opposite operations, such as multiplication, division, addition, subtraction. So, to do that, we need to use a special thing from our toolbox called opposite or inverse operations. As you've heard before, multiplication and division, kind of opposites of each other. They can be used to undo each other. So multiplication, whether it looks like the old-fashioned multiplication, a dot, a constant bumped up against a variable like that, which is multiplication, division, whether it looks like that, or more commonly, we're going to have this fractional bar, and very rarely will we use this in algebra. And then, of course, addition and subtraction, pretty easy. Let's try a problem. When we come to a problem, we see that there's a whole bunch of things that aren't x. We want x by itself at the end of this problem. We want x equals. So clearly I need to get rid of this, and I need to get rid of this. But I have to follow very special rules to be able to do that. I can't just drag everything away. I like to focus on anything extra, almost as if it's like loose change in my pocket. Before I come tackle the x and what's connected to it, I like to get rid of my loose change. I have a positive 7 sitting here. If I look down here, I know that the opposite of addition is subtraction. So the opposite of adding 7 is subtracting 7. And you know the big rule of algebra. If you do it to one side of the equal sign, you have to go do it to the other side of the equal sign. So the opposite of adding 7 is subtracting 7. 7 minus 7 is 0, so those cancel out. And 19 minus 7 becomes 12. So now I'm going to rewrite everything that didn't get canceled. So 3x equals 19 minus 7 was 12. Last step. I see this 3 and this x squished together. What is holding that 3 to this side of the equal sign? It's not that it's positive. That's not what's holding it here. It's stuck to the x with multiplication, and I need to undo that. So if I look down here, what's opposite of multiplying? It's dividing. So I'm going to come in here and I'm going to divide. Opposite of multiplying by 3 is dividing by 3. And if I do it to one side, I'm going to go over here and do it to the other side. Don't be scared that these look like fractions. It's just another way of writing division. 3 divided by 3 is 1. I could write 1x, but I'm not going to. It's invisible, but it's there. The 1 is always there. And 12 divided by 3 is 4. Why did I do all these opposite operations? Because it was able to cancel or remove the number from this side. I got rid of the 7. I got rid of the 3, leaving me with just x. And now I know what x equals. X equals 4. For this particular problem, x equals 4. In another problem, x is going to be probably something different. I just use x to represent something I don't know. If I plugged it in here, 4 times 3 would be 12, and 12 plus 7 would be 19. I always recommend you use a calculator if you're allowed to, because we're here trying to solve two-step equations, blah, blah, blah. I'm not here to test you on your times tables or your basic arithmetic. But your teacher might be, and that's okay. All right, here we go. Lots of negatives in here. I'm going to dive right in. I'm going to get rid of this loose change here. I got to get rid of the 7, the negative 7, and I have to get rid of this negative 4 over here. So let's do that. Opposite of minus 7 is plus 7, and if I do it to one side of the equal sign, I'm going to go do it to the other side of the equal sign. Gone. Bring down everything that I didn't cancel, and 13 plus 7 is 20. Okay, last step. Don't be confused. There's a little negative up here. Doesn't matter. We're not going to lose it. We're not going to forget it. But that is not what is holding the 4 to this side of the equation. How it's being held? It's stuck to the y with multiplication, and we have to undo that multiplication. All right? So we're only going to focus on undoing that multiplication. Opposite of multiplying by a -4 is dividing by a -4. Notice I didn't mess with the signs at all. I had this -4 I had to get rid of. I'm getting rid of it. I have to go divide it to the other side. Those cancel. Anything divided by itself, except 0, is 1. So that leaves me 1y. On my calculator, 20 divided by -4 is -5. A positive divided by a negative is a negative. Negative wins when you're multiplying or dividing. And it meets a positive. It always comes out negative. 20 divided by 4 is 5. Positive divided by negative is negative. Let's plug it in and see what happens. If I plugged in -5 here, -5 times -4, negative times a negative is a positive. 20 minus 7 would be 13. Yes. Ding. I got that right. Good for me. Let's try another one. Ooh, no. We got decimals and fractions. What are we going to do? I do want to, towards the beginning of the semester in algebra, you guys are given a big jumble of numbers and parentheses and everything, and they're like, evaluate this expression. And they tell you, okay, first you start with parentheses, and then whatever's in the parentheses, and exponents. And some teachers use something even more advanced than him does, like parameters and like whatever. But the basic idea is pretty simple. There's an order when we come to a big old jumble of variables and constants, parentheses, exponents, that we should do things in. When we are solving, some teachers like to teach, hey, do PEMDAS backwards. I don't teach it that way explicitly, but the general idea of like, hey, let's untangle our positive and negatives first and then move on to our multiplication and division. It's a pretty good idea. And that's generally how we end up doing it anyways. So let's try it right here. I have this x here. I know I want to get rid of this positive 3 and this negative 8.5 because I want x by itself. At the end of this problem, I want x equals. So I need to move all these numbers to the other side. All right. I'm going to focus on this negative right here. This negative is just kind of sitting on this side of the equation. This positive 3x is sitting here. They're almost like words in a sentence. And when they're like that, they're pretty easy to just drag to the other side. I'm going to drag this whole thing over to the other side. If I wanted to, I could drag this whole thing to the other side just by subtracting it, but that'd be silly for right now. I don't need to do that. All right, opposite of minus 8.5 is plus 8.5. So I'm going to add 8.5 to this side of the equation, and I'm going to add 8.5 to this side of the equation. Now, 8.5 doesn't add to 3x because different family, but it adds very nicely to negative 8.5. In fact, they cancel, and that was the whole purpose. I'm sitting here now with 3x equals 8.5 plus 1.25 in my calculator, or if you want to go, you're on YouTube, go look up how to add decimals. 8 plus 1 is 9.25 plus 0.5. 25 cents plus 50 cents is 75 cents. All right, last step. This is being held here with multiplication. I need to undo it using the opposite of multiplication is division. Ooh, I wrote division in kind of a weird little way, didn't I? I'm going to divide 3 to both sides. Gone. And I'm going to divide 3 into 9.75 and get my answer. I can grab my calculator if I want. Go 9.75 divided by 3. And get 3.25. The way I did it in my head kind of was, I said, okay, how many times does 3 go into 9? I know 3 times 3 is 9. And how many times does 3 go into 75? Well, there's 3 quarters and 75 cents. 3 times 25 cents is 75. I use money a lot to help me figure stuff out. So 3.25. If I was going to go plug this back in up here, Would it work? So 3.25 times 3 we know is 9.75. 975 minus 850 would give us $1.25. Yes. Ding. Good. Ah, a fraction. All right. I don't have a ton of room to do this in, but I'm going to try my best. I'm going to tackle the negative first by adding 7 to both sides. And this is going to become 3/4 y equals 7 minus 1 is 6. A positive and a negative, when you add them together, you basically subtract the numerals. So you subtract the 7 and the 1. So 7 minus 1 is 6. And you keep the sign of whichever numeral was bigger. And 7 happens to be bigger than 1. So positive won that battle. So this stays positive. All right. I called these two-step equations. The way I'm going to do this one is going to turn it into a 3-step. I'm sorry. The second step would be, the opposite of multiplying by 3/4 would be to divide by 3/4, so you'd end up multiplying by the reciprocal to both sides. And that would be your second step. The way I'm going to do it, I don't like messing with fractions that way if I don't have to. So I'm going to come in here with a different color. I know that the opposite of dividing is multiplying. So I'm going to, instead of dividing by 4, I'm going to multiply 4 to both sides. Leaving me with 3y equals 24. Sorry. Leaving me with 3y equals 24. Final boss, the opposite of multiplying by 3 is dividing by 3. Do it to both sides, and y equals 8. That made the fraction a lot easier, huh? I just broke it to pieces because I didn't want to mess with it. Ooh, real world problem. Well, for you guys, some of you, when you were younger, even now, this is a real world problem. See, somebody bought you 1,500 fun bucks, but you had to go buy the crazy little magical beanie for, I don't know how much, 1,400. All you got left now is 185 fun bucks. So let's figure out this problem. You want to join an online game. There's a certain room in your online game that you love, and it costs 35 fun bucks just to get in the door. And once you're in, it costs 15 for each round that you want to play. So it's 35 to get in. That's one time. 35 to join the game. And then once you're in, it costs you 15 for each round. And you have 185 fun bucks. And your question is, how many rounds can I play? How many rounds can I play? Well, you guys are quite capable of figuring this out in your own special way, but let's see if we can use algebra and set up a two-step equation. We have 185 fun bucks. So all the little crazy calculations I have to do are going to come out to equal 185. All right, so I'm just going to set equal to 185. My one-time fee is 35. And I could write it up front, or I could write plus 35 here. It doesn't matter. But that's one-time fee. What costs for each round is this: 15 times each round that I play. I'm going to use a capital R for this. So 15 times each round plus the one-time 35 will give me a total of 185. When I solve this, it's going to tell me how many rounds I can play. So let's jump in here and start using our algebra powers. I'm going to subtract this 35 to both sides. 150. This is held by multiplication. I'm going to divide. And R equals 150 divided by 15 equals 10. I can play 10 rounds. With my 185 fun bucks, I can come in there, drop my 35 entrance fee, and play 10 rounds at 15 fun bucks each. And that will be a fun time. And I'll even bring my magical beanie of destruction, and everyone will think I'm amazing and awesome. All right, have fun. Let's do a quick problem before you assess how you're learning. Something's weird going on here. I see this minus in front of the y, and I know at the end of this problem I'm going to have to get rid of that because I want to know what y equals. I don't want to know what negative y equals. I'm going to subtract 18 to the other side. So I have negative y equals 48 minus 18 is 30. Now I could add the y over here and subtract the 30 to the other side and just do it like that, which is the way I taught when we were doing only addition and subtraction. But now that we're doing some multiplication, let's do it the proper way, is to realize that this is a negative 1 that's being multiplied. All right, once you realize that, you're like, oh, that's easy. What's the opposite of multiplying by negative 1? It's dividing by negative 1. Cancels, I'm left with just a normal y. And 30 divided by negative 1 is negative 30. See, told you when we were done we were going to have just y equals 18 minus a negative 30. So 18 plus 30 would be 48. Yes. Okay. Now is a chance for you to assess yourself. These are some really tough problems. All negatives in problem number 2. Got some decimals in problem number 3. And in number 4, we have a fraction. Don't forget to break it apart using brute force. Go back and rewind the video if you need to learn how to do that again. Pause the video and try these problems. All right, let's see how you did. I hope that you got at least 3 out of 4 right. Let's find out. I'm going to attack the 8 sitting here first by subtracting it to both sides, giving me 28 minus 8 is 20. Opposite of multiply is divide. I'm going to divide 5 to both sides. And 20 divided by 5 is 4. Let's plug it in. 5 times 4 is 20, plus 8 is 28. Yes, got that one right. I hope you did too. Over here, I'm going to attack this minus 6 and add it to both sides of the equal sign. Some teachers like to draw a little line there to help you remember to keep things separate. Negative 3y equals 15. I'm going to, opposite of multiply is divide. Okay, don't get tricked because there's a negative there. Opposite of multiply is divide, and I'm going to divide this whole thing over. That cancels, leaving me just y equals. Positive divided by negative is a negative, just as a negative divided by positive would be a negative. 15 divided by 3 is 5. That is one times table you should definitely know. Negative 5 times negative 3 would be positive 15. Minus 6 would be 9. Fire. Let's add this 3.5 to the other side. Notice I just always kind of leave my x term to deal with last. Add 3.5 over here. That's gone. And now I have 2x equals 3 plus 2 is 5, and a half make a whole. So that would make 6, right? 350 plus 250 would be $6. Opposite of multiply. We're using these inverse operations with great success, aren't we? Plug 3 in. 3 times 2 is 6. $6 minus 350 would indeed be $250. Think that through. Think that through. Those 50s always mess you up. And some of your first jobs are going to be working with money. So you got to get those 50 cents down. They'll trick you. All right. There's a fraction here. I'm not scared. I'm going to add 2 to both sides. Okay. Now I'm going to attack this fraction because I don't like, I'm not in the mood for doing the opposite of so I have to divide a fraction, multiply with a reciprocal, which, hey, go look it up, how to divide fractions. I'm going to break it apart. Opposite of dividing is multiplying. Opposite of multiplying is dividing. 18 divided by 2, x equals 9. Wow, we're good. I'm going to go plug 9 in here. 9 times 2 would be 18. Divided by 3 would be 6. 6 minus 2 would indeed be 4. If you got 2 out of 4, good job. Go try again. Do the whole video again. If you got 4 out of 4, you're a boss. All right. Until I see you in the next video, have a wonderful day.